gear D. Okay. So again, we have to look at the shaft AB. So I still have to copy this whole thing. Come on. Okay. I hope to copy this. Which I think I could. Okay, we're in business. Okay. So the rotation, I'm going to draw the rotation. This is still our rotation. Okay. So now I'm going to draw gear D now. Okay. So gear D. Okay. So this is our gear. I'm going to draw gear D in red. Okay. So this is our gear D. Yeah, that's our gear D. Now the question is this. Okay. The rotation of gear D, so they all share the same direction of rotation, or are rotating with this yellow. Okay, let me draw it more curved, then it looks better. This is still the rotation. Okay, so rotation of gears D and E, right? So if you look at the point of contact between gear D and H at the top, so the force will be acting at the top, right? For gear D. Okay. Now, the confusing thing comes is this. Which direction? Okay. So there are two directions down here. And if you get this wrong, right, your moment calculation is all out the window. Okay, your calculation is viewed as good as useless if you get this wrong. Okay. The question is this. Is it in this direction, the pink, or is it the orange? Okay. So D, we know if we were to look on the transformation, so this is our uh, X or Y, Z, and rotation about X. So which direction is it? Is it the one in pink? Is it your DZ in this direction? Or is it your DZ in orange? Right? And if you think about it, okay, if you apply the rule that is the above one, right, you tend to assume that EY and DZ are in the same direction. And that's wrong. Okay. Why that is wrong? The correct one is this direction. This is the correct one. It's opposing the force applied in EY. Okay. And this is wrong. Right? Why? EY over here is the driving force. Right? EY is the driving force or driver force. Right? Gear D, okay, gear D over here is what we call a driven gear. Okay, I'm colorblind. Seriously, it's called the driven gear. One is a driver, the other one is driven. Okay. So the driven gear, the force, note the driven gear will always, okay, create a resistance to the driver gear. Okay. It will always create a resistance. Always. Right. So in that context, if it's dx, it's not creating the resistance, right? It's following what? If you look at the torque, right, generated by dx is following what? Ey, right? So it has to oppose. So dx is the valid answer. Okay, so dx. So when in that point of view now, so we know that this is our what? Ey, right? Over here, right? You look at the direction. Sorry, I should have used the same color or red. You realize that over here, right? At the point of contact, this happened at the point of contact. Okay, so this is your Ey. We know why, right? And over in your D will be in your dz, and it will oppose. It will go in this direction. Okay, so this is your too much. I think I drew too steep. This is your dz, right? So why is it in that direction? Because it's in the, if I were to draw the transformation over here, this is your x, this is your y, and this is your z. Okay. So same thing for gear C also, right? It's going to resist, right? So this is also your CZ. Okay. That is also your CZ. And we know the value, right? We know the value of our DZ and CZ. Okay. So the value of our CZ and DZ, which we calculate before. So CZ is 6632. Okay, 6632. DZ is our 2487. Is 2487 Newton. And then we have our P730 at gear E. P7. Okay. So this is the most confusing part. Okay. Getting the direction wrong. Okay. And I've been teaching this course for almost 10 times now. Always this part students have problems. Okay. Once you clear this, you're clear. But it's not difficult. Okay. You just need to slow down, or you just need to analyze. Okay. So the thing to analyze is this. Okay. The key points to take back today is the forces of the driver of the motor and the driver gear are in the same direction. I highlight in yellow. The driver and the driven gear always oppose in terms of resistance, right? So if EY is coming down or generating, the EY will generate a torque in this direction, torque in the E direction, right? The DZ will always oppose the torque in the due to the driver, the driven. D is the driven, right? E is the driver. It will oppose the torque. Okay. So from here, we are going to next determine. Okay, the next we're going to determine the reaction. Okay, next from here, once you determine the directions already, we're going to determine the reaction of the bearings at point B, A, and B. Okay, so hey, I thought that's better. Okay. So once we have all this information, okay, the next thing is we are going to determine the reaction forces at point A and point B. Okay. So if we were to look at the position at point A and B are usually used for bearings. Okay, so you tend to put your ball bearings over there at point A and B. So the reaction forces at points A and B can be used to select the bearing sizes. Okay, right? The bearings is dependent on the load, right? So that's where we have to determine our reaction at point A and point B. So to do this, you have to again view this, right, in 2D, right? So again, like what I taught you before in compound loading, right? So we are going to do this in 2D, right? So we are going to view in the, bear with me for another like 5 minutes, okay? We're going to view in the XY plane. Okay, we're going to view this in the XY plane. So we're going to draw the shaft. Right, so they are all in equal distance. So this is our point A. This is for our gear C. Then we have our gear D, point D. Then we have our point E. Then we have our point B. And then we have our point B. Okay. So we know that point C and D, we have a cross. Let me use red. Okay. Like what I taught you all before. This is 6632. This is 2487. And then point E, we have force coming down. And this is 3730. Okay. And at B, the forces will be going up. And at A, the forces will also be going up to support the load. Okay. So from here, we can use static analysis, rotation in Z. Okay, so we're going to do a calculation based on static analysis. So applying applying static analysis, we know that some mention about moment, about the z-axis at point A is equal to 0, right? So you have minus 3730 multiplied by 0.6 plus by 0.8 by is equal to 0. So we can get by is equal to 3730 times 0.6 divided by 0.8 is equal to 3730. So we know that is hold on. We know that is equal to 27. Am I doing this correct? So 246.8, right? 3730 times by it's equal to 2797.98 or 97.5 or 2798 Newton. Okay, and then you take some measure about forces in the y. So you got AY minus by 3730 plus by 2798 is equal to 0. So AY is equal to 3730 minus 2798 is equal to 932 Newton. And they are both going up. Okay, I'm going to stop here. Okay, so I think this whole chapter, I think all of you have to write a summary sheet for it. There are a lot of information regarding procedure and analysis that you have to know. Okay. Again, no quizzes this week. Okay. And homework. There might be no homework. Let me see what homework that you need to do based on the lecture, because you cannot do any homework on shaft design yet. Okay. With this, I thank you for your time. See you all then next week. Bye.